Jai Hind to all. Myself Shikha Agarwal, Assistant Professor in IT Department of Ajay Kumar Garg Engineering College, Ghaziabad. So, today we are going to discuss one more important topic of artificial intelligence. Basically, this topic is being discussed for the students of mechanical engineering so that they can cover their basics about the artificial intelligence. So in this lecture, I am going to discuss about the activation functions. Before we start with what do you mean by the term activation function? We know that there is certain methods so that we can get the output. We require certain functions so that we can move to the output. Then we can say we are talking about the activation functions. So we can say, if we are talking about in the term of definition, we can say it's just a thing, or you can say function that you can use to get the output of a particular node. Then that respect, we can also call them as transfer function. Why? Because suppose if I'm talking about a node X, there is some certain processing or a function is being applied onto this particular X node, due to which we are getting a desired output, that is Y, right? So due to which we can say we are transferring the output. We are getting the transfer function. Why? Because we are transferring from input to output through with the help of that particular function, right? So we can say we are talking about activation functions. Basically, activation functions are those functions which decides whether a neuron should be activate or not by calculating the weighted sum and their further additions within it, right? Whatever the decision is being taken, that should be based on the neurons, that how many neurons is to be active, how the activated neurons work, how we need to do the calculation of the weights and so on. Now, if I'm talking about the activation functions, before we start the different types of activation function, we should also know why we use activation functions in neural networks. Because in the previous lecture, I have covered the concept of neural networks. So when I'm talking about the concept of neural networks, it means we are talking about the activations. We are talking about the neurons, right? So basically, in the case of neural networks, we should know, or we should need to determine the output of a neural network in the terms of yes or no, right? Whether the output value or whether the resulting value that exists between 0 and 1 or -1 or to 1. It basically depending upon the particular functions. Then you can say that is the reason why we require to use the activation functions. Then when I'm talking about the activation functions, we have covered the definition. What do you mean by the term activation function? And why we require the activation function in neural networks. So now we are going to talk about the different types of activation functions. Basically, we can say when I'm talking about the activation function, it is divided in the two categories. The first is called as a linear activation function. The second is called as a non-linear activation function. First, we are going to talk about the linear activation function. When I'm talking about the linear, it means we are talking about the function which is having a identity, right? In which the particular output of the function will not be confined between the particular range. So we can say it can be a line in which you can extend the particular output in a linear value depending upon x. So we can say the linear or an identity function is a line or a linear in which the output of the function will not be confined between a particular range. As I have already told you in the previous slides, that when I am talking about the activation functions, we are talking about the range between either 0 to 1, yes, no, or -1 or 1, right? Depending upon the which type of activation function we are using. But when I am using the linear function, in the case of linear function, the range is not defined, right? So because we are talking about a linear line, so due to which the equation is fx is equals to x, right? In which the value of x depends upon x only, right? And if I'm talking about the range, as I have already told you, that we cannot set the particular range. So we can say we can start the range from in minus infinity to infinity. It can exist between any value. For example, if I say I'm drawing a line, so it can exist between, let's say, minus 8 to 8, right? Or it can also exist from minus 6 to 6. So there are the various examples, right? So the values are not fixed, that it should lie between a single digit values, right? So we cannot say the range is fixed. Now, the second thing, it does not help with the complexity or the various parameters of usual data is being fed into the neural networks. So this is the basic concept of activation function. Now, in this lecture, we have discussed about the second type, that is called as a nonlinear activation functions, which is mostly in the use of neural networks. Now, if I am talking about the nonlinear activation function, basically this is the linear function which is being mostly used, activation function in the case of neural networks. When I am using the word nonlinear, it means there is no linearity into the data. Sometimes the data can go up, sometimes the data go down, there is a downfall. So you cannot give the guarantee for the existence or for the graph. So you can see the graph also. When I am talking about the graph of the nonlinear data, you can see initially the data was rising and there is a certain saturation point, and after the certain saturation point, the graph is to be downfall. So you cannot give the guarantee that it will always give a linear or a line increasing form or decreasing form of type of range. This particular is not giving a initial range. When I am talking about the nonlinear data functions, activation functions, it makes the easier for the models to generalize and to adapt the variety of data and to differentiate between the outputs, right? So that we can understand how we can differentiate the data and how we can talk about the varieties of data. It can be applicable for the different datas, and whatever the output is being generated, we can differentiate between all those output. Now, to understand the concept of nonlinear functions, we are going to talk about the two main terminologies. The first is called derivative or differential. The second term is called monotonic, right? Whatever the activation functions we are going to talk about in this lecture, before that we should understand the term derivative or monotonic. When I am talking about the term derivative, derivative says if there is certain changes in y-axis with respect to x-axis, right? If we are saying that x-axis is increasing due to which the y also changes, then we can say it is called as a derivative or differential function term. So it is also known as slope. The second is monotonic. When I am using the word monotonic, the function which is either entirely non-increasing or entirely non-decreasing, then we can say the function is non-monotonic, right? So these are the two basic terms which we are going to discuss into each and every activation functions. The first parameter we are going to discuss about the signodial or logistic activation function. Basically, this particular activation function is a very basic nonlinear activation function. Generally, we used to do the calculations based on the sigmoid or the sin theta function, in which you can see the curve look like a S shape, and whatever the value of z is being based on this parameter, that is 1 upon 1 plus exponential e raised to power minus z. We have to talk about this sigmoidal function. Into this sigmoid function, the main reason, generally I have already told you that we are using the sigmoid function. So what is the main reason for using the sigmoid function? Because in the case of sigmoid function, generally the output exists between 0 to 1, right? And basically this particular model, this particular function is used for models where we have to predict the probabilities of an output, right? So as we know, everything exists between 0 to 1 in the case of probability. So here by using this function, we are predicting the probability of an output, due to which the sigmoid is the right choice to choose as an activation function. So we can say whenever we are talking about the predictions in the case of probability, then we are going to talk about the function sigmoid, right? Second thing, when I use the two terminologies, in the case of sigmoid function, this particular sigmoid function is a differentiable as well as it is monotonic, right? If I am talking about the function is differentiable, this means that we can find the slope of the sigmoid curve at any two particular points, right? We cannot say you can do the derivation or derive it, that particular function. It can be a monotonic, it can be differentiable, because by using the two particular points, you can generate the curve, right? Second thing, the logistic sigmoid function can cause a neural network to stuck at the training time. Okay. And finally, when I'm talking about the sigmoid function, the softmax function is a more generalized logistic activation function which can be used for a multi-class classification. When we want to generate the classes, different classes of that particular function, or we want to classify the classes into a multi-levels, then we can say we can use the softmax function with the help of sigmoid function. The next we are going to talk about the Tanh function, or it is also called as an hyperbolic tangent activation function. When I am talking about the Tanh function, basically this is like more also like a logistic sigmoid, but it provides a better output, right? Why? Because you can see when I am talking about the sigmoid function, its range exists between 0 to 1, right? But when I am talking about the Tanh or hyperbolic tangent activation function, this particular function, the range exists between -1 to 1, so that we can also use for the negative values, right? So this is also a S-shaped curve. This also generates the S-shaped curve similar to the sigmoidal function, but the range on using in the Tanh is -1 to 1. When I am talking about the Tanh function, the advantage of using this particular function is that the negative values will be the negative inputs will be mapped strongly with the negative and the zero outputs. With the zero, and the zero inputs will be mapped nearly to the zero in the Tanh graph, due to which the function is differentiable as well as monotonic, while its derivative is not monotonic, right? And we can also say that Tanh function is also used for the classification between the two classes, similarly to the sigmoidal function. As in the sigmoidal function, there is a difference between the sigmoidal and Tanh function is that the sigmoidal function is having a range between 0 to 1, but in the case of Tanh or hyperbolic tangent, it is having a range between -1 to 1, right? If I am talking about both the functions, they both are used in a feed forward nets. We'll discuss the one method in the case of feed forward method. Then we will talk about these functions. The next function is ReLU, or you can say rectified linear unit activation function. Basically, this is the latest, or you can say the most used activation function in the world right now. Generally, because our mostly research is being based on the convolutional CNN networks or deep learning. So in that case, generally when we are talking about the activation function, this particular activation is being used mostly. You can see the difference between the sigmoid function and ReLU function. In both the cases, you can check when I'm talking about a sigmoid function, we are getting an S-shaped like curve in which we are using this function, right? And similarly, here we are getting after particular range, that is, let's say we have set the maximum range is starting from 0 to up to z. Then we can say it is being generated a graph, it is being based on this equation. Fine. As you can see, when I am talking about the ReLU, it basically is half rectified from the bottom on the basis of that fz value. And when the z value is less than 0 and fz is equal to z, then the z is either above the value or equal to 0. You can see if this particular value is 0, then either it is above the value of 0, right? It is above or equal to 0. So you can see if it is 0 or either it is above the 0, it moving towards this side. So we can say it is greater than 0. Here we are having a negative value, so it is not moving towards that side, right? If I am talking about the range, in this particular case, the range exists between 0 to infinity. Although in the case of sigmoid function, the range is 0 to 1. In the case of Tanh function, the range is -1 to 1, or in the case of ReLU function, the range exists between 0 to infinity. Right? So we can say there is a difference. Although all the functions and its derivative both are monotonic, right? But there is a slight difference between all these functions. This is, and initially when we are starting with the working with AI, we are using these two functions because these are the basic activation, non-linear activation functions. So we are using these functions. But in the present situation, because mostly we are working on CNN or deep learning, due to which we are talking about this activation function. So on the basis of these activation functions, these are the various categories of activation functions. I've used the word feed forward networks. So we need to understand what do you mean by the term multi-layer feed forward networks, right? Which is also called as a multi-layer perceptrons. So due to which here we are going to discuss about the next algorithm, that is a back propagation algorithm. We understand how the activation functions work, how we need to do the calculations, and on the basis of that how the output is being generated, right? So to understand the concept of multi-layer feed forward network, you can see the one diagram. Into this diagram, initially we will give inputs. So when we are talking about to giving an input, there is an input layer. Onto that layer, there are the two functions, x1 and x2, right? Into which input for x1 is 0 and the input for the x2 is 1, right? Then after that, as we know, when I'm talking about the neural networks, it goes into the three different layers: input layer, hidden layer and output layer. So there is an input layer in which we are having a two parameters, that is x1 and x2. Similarly, it can be an n number of output also. Here I have used a single output, so you can understand the concept by that, but it can generate the many output also. So this is called as an output layer, into which we are talking about y. Whatever the input is being getting into the y element, that is being getting as an output, right? Now in between there is an hidden layer. This particular hidden layer, using an activation functions to do the calculation, and into which they have to work on the basis of inputs, and then after that for the output layer, these layers, these z1 and z2 work as an input, and on the basis of that will again apply the activation functions and we'd finally get the desired output. And in the case of multi-layer feedback forward network, output is already given, right? We match, if both the values are similar, then we have achieved the target. But if there is a difference between these two values, then we can say there is some error. So we need to rectify that error. Fine. So this is the way how the multi-layer perceptrons work. Let's discuss one example. So as I have already told you that in the case of multi-layer feed-forward network, or a back propagation algorithm, which we will explain one example here. It contains the 3 layers. For the first is input layer, which is having 2 neurons, that is x1 and x2, as you can see. Then after that, we are having a hidden layer having 2 neurons, that is z1 and z2, and finally we are having only a 1 output layer with a 1 neuron, that is a y input, right? So let's see one example of the back propagation. Here we will solve this particular neural network of the neurons, in which we are using the sigmoid function. Here we are going to use the sigmoid activation function. What is sigmoid activation function? That particular activation function is equals to 1 upon 1 plus e raised to power minus x. This is the activation function for the sigmoid activation. Here what we have to do? We have to do or perform a forward pass and a backward pass onto the network, in which we have already assumed the actual output is 0.5. So we can say we have already know what is initially is given as 0.5. Fine. And then we know the learning rate is 1. Whatever the learns, we are doing it, that is only 1. So into that case, what we have to do is, we have to do the calculations. How we have to do? See, these are the 2 inputs, that is x1 and x2, right? These are the 2 hidden layers, or you can say hidden layers input, that is h3 and h4, and finally we are getting an output, that is O5. Right? And similarly, remember one thing, there is one more parameter that is called as bias, which shows the certain errors residuals. So we need to use that bias values. Fine. So by using these inputs, you can see when I'm moving from x1, then the weight from x1 3 is equals to 0.1. Understand? Similarly, if we are moving from x1 to h4, so the weight for h1 4 is equals to 0.4. This is the way how we are using the concept, right? Now you can see the example, because they have told into this example we have to perform another forward pass method, right? So for that sake we have to do the certain calculations. First of all, whenever we need to calculate the values of A, right? Into that case, what we have to do the calculation, first of all we have to calculate the summation of that particular nodes, right? So first of all, while calculating the weight on a particular node y3, for calculating it, whatever it is being inputting it, we need to calculate that weight, right? So into that case, the formula is, we need to calculate the yi. So it means we have need to calculate the function on y3, right? That is equals to 1 upon 1 plus e raised to power minus y3 की जो भी value generated, right? So into that case, first of all we should know what is the value of that y3. So for that y3, we should know that we are using the one more parameter, that y3 is equals to aj, right? Or you can say y3 is equals to function of aj, right? So then what is the function of aj? Aj says that we have to do the summation of their weights and their inputs. Fine. So let's talk about y3. In the case of y3, you can see there are the weights coming from the 2 inputs, that is x1, y1, right? So while calculating a1, what we have to do? Weight of 1, 3. that is coming from x1 to 3. So weight 1 3 into x1 plus weights, how it is coming from x2 to y23, right? So y23 into x2, fine. After doing the calculation, suppose we are getting an output as 0.755, right? So after calculating that value, now what is this value using? That is an AJ, or you can say A1, fine. After putting this particular value into this function, so as I have already used y3 equals to this function, then we are getting this value of y3, that is 0.68. So here you can say y3 is 0.68, right? Similarly, we need to calculate the value of y4. After calculating the value of y4, suppose we are getting 0.6637, right? So we have calculated both the hidden layer values, fine. Then similar pattern we need to apply onto the output range. It is coming from the y3 and y4. So here we can use the weight of y3 and y4. We'll do the summation into that with multiplying with their own weights, and after that when we are calculating, we are getting 0.8101. Then we have to apply on the activation function, on the sigmoid function, then we are getting a 0.69. So finally, this is the network output which is being calculating based on the given function, that is a y5, that is equals to 0.69, right? This is the output which we are getting into this value, right? After getting this output 0.69, now I have already told you initially the actual output is already given, that is 0.5. It means after getting that actual error, we need to calculate the complete process, how the error is being retrieved. So into that case, you need to calculate error. If 0.69 matches with the value of actual output error, then you can say ki there is no error into the system. But if both the values does not match, then you need to calculate the error. Then we can say error is equals to y target minus y5. What is the target value is already given, that is 0.5, and what is the actual value is being generated, that is 0.69. So you need to calculate the output, that is minus 0.19. This particular error is not 0. So this particular value indicates that while using this network, there is certain errors into this particular network. So into that manner, we need to do or doing a backward fed neural networks, backward mechanism to remove this error. This is the way how the back propagation network works, fine. Now in the last, here we are going to discuss about the certain applications of neural networks. As we all are aware that in each and every field, generally we are using the neural networks, right? In the various in the various key sectors, we are talking about the neural networks. The first, we are talking about the face recognition. Whenever we are talking about the system's surveillance, the face recognition system serves robustness. The second, as I've already told you, deep learning and CNN, they are in the most common areas where we are using about the neural networks. So we can say the second application is CNN, that is CNN. Basically, CNN are used for facial recognition and image processing. Whenever we are having a large number of pictures that are fed into the database for training a neural networks, they collected images and they are further processing it for the training purpose. The next, there is a stock market predictions in which we have to predict the market in the real time, in which the multi-layer perceptrons or that particular back propagation algorithm works. In the case of social media also, right, and the in the field of defense also. With the help of neural networks, they are used in logistics, armed attack analysis, and for the object's location. So that in the case of services, defense services, we can easily identify the particular objects. And in the last, we are talking about the healthcare. As the CNN is being used in image processing, so it will also be very helpful in the case of healthcare. By using the image processing, we can easily retrieve the data from the aforementioned test that is being analyzed, and the basis of the neural network models, we can easily access or examine the patients. These all are the various applications where the neural network works. Thank you.